learn about polar coordinates. Polar coordinates are determined by a ray within point at pole origin r theta. Represents the point r units from the origin, blah, blah, blah. An angle theta clockwise direction. The rotation is clockwise as far as negative. Strike the ray in the x direction. You'll see what this all means in a second. Plot the points with following polar coordinates. So to plot the point, so this is a polar graph, okay? And to plot a polar graph, what you do is you start, this is called the polar axis. You start at the pole, that's like 0, 0, okay? And you end up the same place you would end up with rectangular coordinates, except you get there by doing a moving out along the polar axis and then a rotation, rather than moving in the x direction and then moving in the y direction. And so I'm going to go out. I'm going to use this graph because it's kind of easier to see. Okay. So let's call this. So this would be pi over 2 here, right? And this would be pi over 4. And so this would be pi. Wait a minute. That's pi over 4. Then that's not pi over. Would this be pi over 3? Pi over 3, I guess.
Yes.
Yes?
Yes.
It's kind of, it should be right.
No, it's right there.
Should be
Perfect. You're good.
pi over 3, and this should be pi over 6.
Yeah.
I don't think that makes sense.
No, that makes sense.
Because that would
What it
be.
says on the left.
Is that what that says?
Yeah.
Oh, it does. Okay, so we're okay. So this would be pi over 12 and so on and so forth. So to get to 3 pi over 3, you come out this way, 1, 2, 3, and then you rotate through 5 pi over 3, and the rotation is always in the counterclockwise direction. So this would be 3 pi over 3. This would be 4 pi over 3. So 5 pi over 3 would be pi over 3 past there. So you would go to right over here, right? Yes? Yes.
So that's
Okay.
11 pi over 6.
What?
That's 11 pi over 6.
Oh, you're right. Okay, sorry. So this here would be that point, 3, comma, 5 pi over 3. And since pi over 3 is 60 degrees, 5 times 60 degrees would be 3. Yeah, so it's 300 degrees, right? Okay? You get that? Yes, sir.
Can you go with a 5 pi over 3 pi? How do you go?
How do I get this part? Pi over 3 is 60 degrees, right? So there's 1 pi over 3. Right? There's, okay. Okay. If I want to get to this point, I go over 2, and then I wrote, since it's a negative angle, that means I rotate backwards pi over 4. So this would be negative 2 comma, or 2 comma negative pi over 4, right? 2 comma negative pi over 4. Yeah? Get that? Okay. To get to this point, 3, 0, means you just come out here, and there it is. You don't have to rotate through anything. And then if they have the radius, this is the radius here, if they have that being negative, that means instead of going this way first, you go this way first. Okay, so you go back 2, and then you still rotate through a positive pi over 4. So that would put you right there. That'd be negative 2 comma pi over 4. Questions about that so far?
You don't connect any dots?
No, you don't. Not when you're graphing a polar graph, you do, but we're not going to do that. Yeah, we'll graph polar equations, but we're not going to do that. Next section. Okay?
Is this just like a math thing, not like a real world?
So anyway, right, other point, so can I erase this one? This one here? Sure you can, because I'm going to use the same graph. Oh wait, oh I'm recording right. Gotta erase everything. Now I am. So to get here, I go over 2, and I rotate through pi over 4, right? And what they want to know is how else could I get to this point? Lots of different ways. Who can give me one way I can get there? Other than just coming out on that.
-2,
Yep.
and -7 pi. 3 pi.
Close. Good. Very good. Okay. Oh, they see him good. Good try there. So you go this way. Okay. And so one way to get there would be to go -2, or not, sorry, 2, and then 7 pi over 4, right? Negative 7 pi over 4, because you're going to rotate in the backwards direction. Come out here, and then rotate through in the negative direction. What's another way I could get there?
-2.
Yes. Oh, Jay. -2 what?
-3 pi.
Good. Yes. -2, -3 pi over 4. And, oh, that's what you said the first time?
Yeah.
Sorry. Okay, and then, right, because you could go back 2 and then rotate in the negative direction, 3 pi over 4. Or, what? Or I could go out 2, and then I could go all the way around the circle twice. Yes, sir.
Oh, yeah, I was gonna ask if you could have it be like -2, -11 pi.
Yeah, you could go that way, or you could go +2 and then go pi over 4 plus another 8 pi over 4, so 2, 9 pi over 4. So that's 3 ways. Those are not the only 3 ways. Right?
There's an infinite.
There's infinite ways. All right. So, any questions about that? Okay. Next one. Going back. Let's go to this. Oh, not more math. Yeah. Right? 3 other. Oh, we did that. Plot the point 3 pi over 6 and find other polar coordinates. So pi over 6 we decided is this one, right? So we're going to plot go to 3, 1, 2, 3 pi over 6, right? And find other. So what this means, people always get this one on the test wrong because they don't know what it means. So what you want to do is have a positive r, but you want to get there by going at least 2 pi. So I'm going to go out r, and then I'm going to go like that, right? More than 2 pi. So what would that be? 3 comma what? How many pi's over 6 would that be? I'm going, yeah, not 7. Because how many pi's over 6 is 1 revolution? 13. Thank you, Drew. 13 pi's over 6. Very good. Because this is 1 pi over 6, right? And I want to go around again, and each time around is 2 pi. And in terms of pi's over 6, that would be 12 pi's over 6. So this one says I want r to be negative. So I want a -3 for r, but I want my angle to be positive. So how could I get there by coming 1, 2, 3 in the negative and going this way? How many would that be? Thank you, Brad. 7 pi over 6. Do you guys see that? I got there? Go back 3 and then rotate through 7 pi over 6. And this one says I want r to be positive, 3, but I want to get there by going in the negative direction. So how far would I have to rotate in the negative direction? Good. -11 pi over 6. See, isn't this easy? Easy. Got it? So now we're going to move on.
Your homework.
No, not quite. We got to flip on to the other side. I'm sorry. Okay.
That's so much homework.
Homework. No,
Holy
yeah, but it's just
crap.
like graph this point.
No.
Okay? What?
Graphing sucks.
So,
11.
yeah,
Yeah.
okay. Anyways, where this comes from, let me just show you. Say I had a little graph. I want to draw a little graph here. And here's a point. Here's a point hanging out here, x1. Okay? And to get to this point, right, I would go over x, and I'd go up y. Yeah? And this would be theta. So it so happens that if I want, and this is r in this case. So to get y, you would know that sine of theta is equal to y over r, and cosine of theta is equal to x over r. And that's where these two things come from. X equals r cosine theta when I multiply through, and y equals r sine theta. And these are important to know. So that's how you convert. So use conversion. So this says use a conversion formula to convert each point to rectangular, and graph both polar and rectangularly. Okay. So 6 pi over 6 would be so x is going to be r cosine pi over 6, and y is going to be 6 sine pi over 6. And then you have to know your unit circle a little bit. This is 6. Anyone remember what the cosine of pi over 6 is?
That's the
It's root of 3 over 2. So this ends up being, those cancel out, and you get 3 root of 3, comma. And this, anyone remember what the sine of pi over 6 is?
1/2.
1/2. So it's 6 times 1/2, which is just 3. So to convert this into rectangular form, it's called, it would be 3 root 3, comma 3. So to get there polarly, I guess you call it 1, 2, 3, 4, 5, 6, and rotate through pi over 6. To get there, rectangularly, you would multiply 3 times root of 3, which is about 1.7. Okay? So what's 3 times 1.7? You guys know, about 5.2 or something like that? So I'd go over 5.2, 1, 2, 3, 4, 5, and a little bit, and then up 1, 2, 3. And you can see that it's kind of the same point, whether I'm graphing, it should be the same point, whether I'm graphing polar, on a polar graph or in a rectangular graph. You follow? Follow, 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 follow. What? That's from a musical. That is a musical. Okay. I won't go there right now, though, because we're being recorded. This one would be negative 4 cosine of negative pi over 4, comma, negative 4 sine of negative pi over 4. And so the cosine negative pi over 4, that's down here, right? So that is positive or negative. Cosine positive or negative over there. Over here, is x positive or negative? Positive. Anyone remember what the cosine of pi over 4 is? Math cheer. Math cheer. Root of 2 over 2. Okay? And this is negative 4. Sine is negative in the fourth quadrant. So that would be negative 4 times negative root of 2 over 2. So this is negative 2 root of 2. And this is positive 2 root of 2. Okay? And so this point puts you at back root of 2. So root of 2 is about 1.4. So 2 times 1.4 is about negative 2.8. So back about, whoops, if I were graphing it rectangularly, back about 2.8, up about 2.8, so somewhere around there. If I'm doing it in polar form, it says go back 1, 2, 3, 4, and then rotate backwards 2 pi over 4. So it looks like it's in about the same spot. See?
So why did you just get rid of the negative 4?
What?
The negative 4s?
Why is this negative?
No, why'd you get rid of the negative 4s?
Oh, over here?
On both sides, yeah.
Because this is a negative times a negative, so it turns in, when I simplify this, it
Oh, I
turns
see,
in.
okay.
Okay? All right, moving on. Moving on to this. Oh, there's more? Oh, no, it's okay. So I got to tell you. Converting from rectangular to polar coordinates. So r, because of the Pythagorean theorem, is equal to the square root of x squared plus y squared. And theta is the inverse tangent of y over x. And you can see that from that little picture I drew wherever it went to, okay? Right? Tangent theta is y over x. And the only thing you have to be aware of is that it can be in a, you have to be aware of the quadrant you're in when you find the angle, okay? So for instance, find the polar coordinates for the following points. So to find r, oh, you're in the basketball team? All right, to find r, okay, r is going to be the square root of 2 squared plus negative 2 squared, and that is just r equals the square root of 4 plus 4, right? Square root of 8, which can be simplified to square root of 4 times the square root of 2, which can be written as 2 root of 2, right? You see what I did? Okay, that's r. Now to find theta, you got to be a little bit careful, okay? So 2 minus 2. So 2 down to, I'm in this quadrant, okay? So if I take the inverse tangent of negative 2 over 2, negative 2 over 2, that's an inverse tangent of negative 1, your calculator will give you the correct angle, which is negative 45 degrees, okay? So that's okay in this case. So to turn this from rectangular form to polar form, it's going to be 2 root of 2, comma, negative 45 degrees, or negative pi over 4. You follow that, what I did? Which makes sense. Now, you have to be careful in this case. So, again, to find r is going to be equal to, I'm doing letter B. Here, let's make it bigger, or get a picture of it, so that those of you viewing this at home can get a better picture, right? All right, so in this case, r is going to be the square root of, you don't really have to worry about the signs, because when I square them, everything's going to be positive, right? So I get r equals square root of 1 plus square root of negative 3 square root of 3. So r just comes out to be what? 2, right? But now I gotta have to find theta. So you want to find the inverse tangent of negative root of 3 over 1. Does anyone remember, whoops, over negative 1. So that ends up being the inverse tangent of positive root of 3. If you plug that into your calculator, or if you know your unit circle, which you should, how many degrees would you get? Oh, I'll tell you, 60 degrees. However, this angle, or this point, is not, that's not very good, is not in the first quadrant, is it? Okay? Which quadrant is this point in? It's in the third, right? It's back 1 down root of 3, right? So what I need to do, if I end up getting this is 60 degrees, I just add 180 to it, you see? Okay, so the angle theta, that's why it says be careful which quadrant you're in. So r is 2, but theta is not 60, but 60 plus 180, or 240, or 4 pi over 3 radians. Okay, and this one over here, that's pretty easy to see. 0, 3 would be here. So r, you don't even have to do the Pythagorean theorem. To get to this point, I would just go out 3 and rotate through how many degrees? 90, right? So this is the same as 390 degrees, or 3 comma pi over 2. Okay? See? Yes?
So, the first one you wrote it in radians.
The first,
B, and then, well, A you wrote it in radians, and then B you wrote it in degrees. Does that
yeah, it'll say, right, the answer in radians, or right, but I'm just trying to, so this is both, right? This is just degrees, so And radians, this would be 4 pi over 3 radians. Okay? All right, moving on. Sorry. 2 more problems. Transform the equation R. There's a little trick here. Okay? So if you see one that looks like this, transform the equation into rectangular form. Okay? Hey! Talk to him. The way you do that is you, how do you do that? You multiply through by r, and let me show you why. I'm going to multiply this equation by r on both sides, and r times 4 sine theta, because this becomes r squared, and if I distribute this r through, I get 4r sine theta. And what's r squared equal to? If r is equal to the square root of x squared plus y squared, what's r squared equal to? Yes, r squared equals x squared plus y squared. And 4r sine theta is, what is it? Look on your sheet. It says on the top. What's r sine theta? What's r sine theta is y, so this is 4y. But unfortunately, they don't want you to leave it like that, because they want you to recognize this as something special. Okay? And the way you get this to be something special is you bring that 4y onto this side, and you set it equal to 0. And guess what you have to do now? Your favorite thing. What's that called? Equals 4. You guys know what I just did? I completed the square, right? Because y squared minus 4y is equal to y minus 2 squared, plus, when I do this, I have added 4 to this side. So I add a 4 to this side to balance it out. Does anyone know this? What this is the equation of? What's that the equation of? X squared plus y squared equals something. Don't you remember? A what?
Circle.
A circle. That's an equation of a circle with a radius of square root of 4, which is 2, and a center at 0, 2. So this would be a circle that looked like this. Like that, with a radius of 2. Okay. Now, you could also graph things on polar form in your calculator. But we're going to save that for later on, because I don't want to mess with that right now. Okay, so if you could plug this equation right in. We're not done yet. Where are you going?
This is my time.
Okay, I got 5 more minutes. All right, last thing. So convert this from rectangular to polar form, and this one, it doesn't really turn. This is I believe this is a hyperbola. If you graphed it, we're changing this into polar form. So I know that I can write this as 4. What's x equal to? Look on your sheet. R cosine theta. And y is r sine theta. And 9 is just plain old 9. Okay? And then when I simplify this, I get 4r squared cosine theta sine theta equals 9. Now what they do, and if you just left this on a test, I'd be okay with that. Okay? It's kind of nice to solve for r, but then you'd have to break it into 2 parts, and you can't really put that in your calculator either. What they do in the book is this. They take out a 2 from here, and they rewrite this as 2r squared times 2 sine theta cosine theta. I kind of rearrange things. Does anyone know why I rearrange things? Does anyone remember what this is equal to? That's an identity.
1.
Yes. What's that, Kate? Sine of 2 theta equals 9. And then you could write that as r squared sine of 2 theta equals 9 halves. And that will give you a special shape if you graph that on your tablet. Okay, what I did is I just factored out a 2 from this 4, and then I rewrote it with a 2 sign. I rewrote this, rearranged these two, because this is equal to sine 2 theta. Remember that those double angle formulas? That's where that comes from. But if you just got to here, that's okay. Okay.